This lecture will be about autonomous vehicle and is it present or future. Our speaker, Nemanja Stefanovic, will speak about the story, how modern technology affects our life. Currently Nemanja is working on a startup that will change the way people find job. He's a drone enthusiast and developer and entrepreneur. So please give a warm welcome for Nemanja.
Thank you. Can you hear me? Okay, cool. So first, I'm sorry that I'm a bit late. I was traveling from Belgrade and I had a video conference that I couldn't delay. It's good to see like this many people last year. I also had the lecture about drones. Drones are my passion, so at that time I was more into that, but as I'm already presented as a startup founder, at that point I was starting the startup about changing the way people find jobs, and we got an investment. So mostly last year I was doing that project. I didn't have time for drones or anything else. And our idea last year was to organize a drone workshop this year, but unfortunately I didn't have time to organize that. So I'll talk about something that I'm very fascinated in the last few months and something that I'm reading a lot and researching. So that topic will be autonomous vehicles. And after this lecture, I'll be quite short, like maybe 40-45 minutes. And after that, I want to have a discussion with you about your opinions about that kind of technology and how you see that future, or do you think that that's the present or that the technology will improve in the future? So first of all, I'll start with the funniest slide. And as you can see, like it's a police officer that stopped the car and he asked, why were you speeding? And he said, speeding officer, please ask the car. I don't know. So this is quite old, but this is something that's really happening in the world right now. Cars are really driving themselves, and people are less driving the cars than 2 or 3 years ago. So I'll start from the beginnings, how the autonomous cars started their story. So in the 1930s, there was a very big world fair in New York, and it was very different than other world fairs because it presented the future of the American dream. And all the cars were, not all the cars, but there were cars that were autonomous. They tried to show how the future will look like. It's called Futurama. The theme of that show was Futurama, about how the world will look in 50 or 100 years. So they presented, I think General Motors presented the car that was autonomous. It was following a rail. And that's the first signs of autonomous cars. Of course, then the Second World War happened, and all those dreams about self-driving cars vanished. People focused on other things to make weapons and not cars. But then after the Second World War, came the Industrial Revolution in America, where technology from the war started going to private hands. And a lot of companies that produce cars thought that driverless cars will be the future, but not future as we say it. Like they believe that will happen in 10 to 15 years from that point. And on the right side, you can see advertisement from '57, where two families or two couples are driving in their car, but they don't drive the car. They play, I think, Scramble or something like that. And the highway has a center line that the car is following. And they believe that this will happen in the next 10 years at that point. So that's the '60s. But of course, that never happened. The technology was very robust and very analog, so that couldn't happen at that point. Later on in the '60s, those dreams vanished, but they still tried to make something that was self-driving. So in the UK, they tried different approaches. One of the most successful approaches at that point was to lay cables with the magnets under the road, and the car is following those magnets. So it has the sensors, so it senses where the magnets are and follows that path. The main problem with all those ideas at that time and technologies, that they were too expensive. You couldn't put that kind of technology just into the car. You had to build an infrastructure, completely new infrastructure. So you had to build completely new roads with magnetic stripes in them or whatever. And of course, it wasn't that reliable. Accidents happened. And of course, it was too analog. That's before the digital revolution, before the microchips. So at that point, a lot of manufacturers tried something. Most of them failed. I think Chrysler made a very interesting car called Firebird. It had also a system so it could drive itself. It used the rail on the side of the highway, and so you connect it to the rail and it follows the rail. But it could also sense when someone is in front of them. But that was too expensive. You still had to build the rail. You still had to build the highway, so it wouldn't work that way. So then came the revolution. Microcontrollers, microchips, that was the biggest revolution for us, of course. But at that point, people understood that they could take that analog technology and bring it to the digital age, put microchips in, put processors, and it could do things that they couldn't do before. Also, computer vision became a thing. They started in the 70s already. They started using very primitive CCD cameras to sense motion, to sense different objects in the path. And they coupled it with digital processors that could understand that and create some kind of computer vision. And one guy was a pioneer in that thing, and he did some cool stuff. And his name was Ernest Dickmann. He's a German engineer, aerospace engineer, but he was very interested into self-driving cars. And in the 80s, he and his team built they took a very normal Mercedes car and they put electronic chips into it. And it's called VAMORS. That's shortcut, I don't know exactly for what. And it used two cameras to create a stereoscopic view. And it used very, very simple 16-bit processors at that time. And they successfully drove it for 20 kilometers on itself. So the car had a programmed path. It knew the surrounding to some point. They always had the driver, of course, behind the wheel if something goes wrong. But it drove for 20 kilometers. Later on, the same team further developed that model. And in '94, they created the VAMP. That's the successor for the VAMORS car. And it had better, of course, cameras, better microchips. And it could sense road signs. It could sense obstacles, it could sense other cars. The car knew in which lane it was, and they successfully tested the car, driving from Munich to Copenhagen. That's some 900 kilometers of road, and the car was 95% autonomous. So only on 5% of that 900 kilometers, the driver took the car, but everything else was done by the computer. Then again, the development of microchips, more microchips everywhere, cheaper, everything else. So came the 2000s, after the dot-com bubble. And the US government saw the potential in driverless vehicles, driverless cars. And they started financing through DARPA and through US Army, financing private or government-funded competitions to see which private team could build the better driverless car. So there was few demo days or demo projects that they organized, but none of them were actually that successful until 2004, 2005. I think it's 2005. So the idea behind those demos was they created the test track in the desert. It was 140 miles, so around 180 kilometers, and it has various landscapes, roads, rocks, trees, everything. And the car was programmed to come from one point to the end of the course, and most of the teams really failed. But then, all the major manufacturers of cars at that time tried to do something with the autonomous cars. They tried building it, they tried testing it. There's like, here you can see General Motors, Ford, Mercedes, Volkswagen, everyone tried. It was hard because they didn't still have the knowledge to do that. They're more focused on classic cars, and that's probably the biggest problem and obstacle for them, because they're too focused on classic cars, where you buy it, you drive it. They don't think that innovative technology will change the driver, because if that happens, probably their sales will drop. But still, again, new chips, new computers. We have like, this thing is stronger, have more processing power than the Apollo mission computer, and it's cheaper, 10,000 times cheaper than that, probably. So that kind of technology really made it very simple for people to try out to build autonomous cars. So there's two major players that saw the potential in that, and that's definitely Google and Tesla. They started thinking about autonomy. They had the technology, they had the engineers who can do that, and they wanted to try. So I'll call this thing like the Google way, and we have a Tesla way, and we have a third way that's more interesting than both of these. So as I said, DARPA, which is US Defense Ministry's, how would I say, extended, I don't know how, that's the agency that deals with innovations in the defense ministry in the US. So as I already said, they started a few challenges for people, for private teams to build autonomous cars. And there was one team in 2005 that was very successful. They completed the course, and that was the team from Stanford University. And that team was the team that later on moved on to Google to develop the autonomous car for Google. At that point, Google didn't have the interest to build autonomous cars for the masses. They needed it for themselves. They started a product called Google Street View, and they needed a cheap way to map the whole world and to film every street and everything. And their idea was to create the autonomous car that drives itself wherever and takes pictures of it. So it's like a good combination, because it already has cameras, and why not use that information in real time to guide itself and take pictures. They used to modify regular cars and put lidars on and put collision sensors and detectors. And it was a very simple way to do that, because their investment in one car was around 150,000 euros, which is relatively cheap. And the most expensive part was the lidar, which they had to buy, and it cost around $80,000 at that point. But of course, the world changed. They didn't need autonomous cars anymore for that project, so they saw potential to create autonomous cars for the masses. And as you can see on the right, that's Google's first autonomous car. That car doesn't have pedals, it doesn't have a steering wheel, it has nothing. You just sit in it, you tell where it wants to go, and you go there. And in 2016, they have traveled, Google's autonomous cars have traveled more than 2 million kilometers completely autonomously. So that's good feat. Currently, I think they have more than 150 cars that they're testing on, different platforms, different cars. Okay, so now we're coming to the Tesla way, which in my opinion is more interesting than the Google's way. So Tesla didn't have any intentions to create a driverless car. They wanted to create an efficient car, a car that doesn't pollute and everything else, but in the beginning they didn't think about driverless cars. So as they put that kind of technology into a car, it has serious computing power to, I don't know, to distribute the power between the drivetrain and the batteries and everything else. It has navigation, it has everything. So it has very strong microchips and computers. They started thinking, why wouldn't we use that computing power to create a car that will be driverless? And at that point, that was very secret. People didn't know what they were building and thinking about. But in September 2014, all cars after that have an integrated video camera in the windshield, and they have radar detectors and ultrasonic sensors. Before that, some did, some didn't. But after that, every car that they produced, every Model S, has those kind of equipment. And the most interesting thing is that actually the autopilot in the Tesla is just a software update. So you don't need to have any special equipment. That's the equipment that you already have in the car. Yesterday you didn't know it could drive itself. Today you get an over-the-air update, and now it can drive itself. So that's by my opinion, a very strong thing, that you can change something by an update, and you just give a complete new set of features. Those features didn't exist yesterday. Today you can summon the car so it comes in front of your building. There's a citation what Elon Musk said here, and he said full autonomy is really a software limitation. The hardware exists to create full autonomy, so it's really about developing advanced narrow AI for the car to operate on. So they just understood that they already have enough electronics, they already have enough brain power in the car, just make an update and it will work. And this is a hacking conference, so I'm coming to the third way, which is my favorite way, and I like this guy very much because he did some cool stuff. And yeah, first equipment, but I don't know if this is that important. It has 3 sensor types. This is for the Model S. Sorry, I skipped this part. As I said, they have very simple equipment, just a front-mounted camera. They have a radar system in the bumper, and they have ultrasonic sensors that cover 360 degrees around the car. So it's very, very cheap equipment. Probably the most expensive thing is the radar component. Everything else is very, very straightforward and simple. Yeah, so we're coming to the third way, and this is the hacker's way, how to build the autonomous and self-driving car. This guy on the picture, that's George Hotz. He uses an acronym on the internet called GeoHot, and he's famous for 2 things. First, he was the first one who jailbroke an iPhone, and second, he was the first one who jailbroke PS3. So the guy is quite brilliant, and I watched quite a few of his interviews, and the thing is that he just said, like, why would I build a car that drives itself? That's the only thing that was in his mind. Why would I buy something that expensive when I can build it on my own? So he started thinking about that, and from the moment he started thinking, in a few months, I think 3 or 4 months, he already had the car that can drive itself. The biggest investment in everything that he did was to go out and buy the car. And the car costed, I don't know, $40,000. Everything else was quite cheap in that sense. He also had problems because he didn't know how to couple the car to a computer, because he bought a Honda or a Acura in the US. So he thought a way how to do that. He started going on a course for Honda's mechanics, and he finished the degree to become a Honda mechanic, and then he got all the manuals for the cars, I don't know, at his home. So at that point he knew how to connect to the car. That was the biggest problem at that point that he didn't know how to solve, but he solved it. This is the trunk of his car. He uses a very simple equipment. It's not even a laptop, it's a desktop computer that he puts in his trunk. He uses a AC-DC converter to convert the power from the batteries. I don't know, I guess he has some UPS, or I think that would be smart, but I don't know if he used that. He uses very simple network cameras that he puts on the windshield. And the interesting thing is he uses Linux, he uses Ubuntu, and he created a very simple script. I mean, when I say simple, it's much simpler than Tesla's autopilot. It's still not that simple because it's machine learning, but the whole script runs on Python. And the main difference between this system, or GeoHot system, to the system that Google uses or Tesla, is that this system learns much quicker by the way how you drive. So Tesla is working in a completely different way. They run simulations on their own computers to simulate every occasion that can happen when you drive a car, and that's very time consuming and power consuming, because he has to know every single thing that could happen in front of your car, if somebody runs in front of your car, if etc. But GeoHot thought that this was very inefficient because you need raw computing power to do that, and his algorithm is built so it learns how you drive. So at first moment when you start the car that has his system in it, you cannot let it drive itself, because it needs at least few days to learn how you drive. And even at that point, when it learns the basics, how do you start the car, how do you change the gear, even at that point you can only turn it on for like 5 minutes. And those 5 minutes are, for example, a normal stretch of road where there's no traffic. But it learns. Next time you turn it on for 10 minutes, 15 minutes, 20 minutes, at some point the computer will learn how you drive and what's happening around you, and it will know how to react. So that's the most important difference to what he's doing to what Tesla or Google is doing. They're trying to put every situation into the car, and this way you teach the car about those situations. So it's completely done through machine learning and big data. He collects every data that he can while you drive the car, and the computer analyzes it and does the computations and creates situation that so the car knows what's going to happen. There's a funny story. When GeoHot wanted to present his car to the media, he went to Las Vegas. I think that it was some kind of computer conference there, and there was one huge problem. GeoHot, where he lives, the lane dividers are white lines, like in Serbia. But in Las Vegas, it's not like that. They have some form of bumps that are not white, they're orange. And he couldn't sleep because the whole idea was to put a media guy into the car and let the car drive them. And he didn't test the car. He didn't know how it will react on the bumps, not on the white lines that the car is usual to. And he couldn't sleep that night. And he took it for a drive the whole night. He drove it around Las Vegas. And in the morning, it worked perfectly. The car knew how the lane divides itself by those orange cones or bumps. So at that point, he knew that the system is really working and that it is reliable to learn about the environment and about everything else around it. And here's a very, very clever thing that he did. Because he's one guy, he did start a company, but they have some form of investment, but he didn't want to invest into a large fleet of cars and everything, and he has only one car. So how will he learn the system about the situation that didn't happen to him? If there was a car in Las Vegas, he would know that the lane dividers are not lines but bumps, but he didn't have a car and he didn't have the money to buy a car and to send one to Las Vegas. So he thought about very simple thing to do. He created an app that you turn on and you put your phone into the windshield and it films everything you do. It takes data from your accelerometer and every other sensor that you have there, and it films. And it uploads those video recordings to his server, and then he just runs the machine learning algorithm and it learns what happened to you in your car. And you earned credit for filming. So it's a very simple and very cheap way that's actually growth hacking. He hacked the system that he would need much more money to do. He hacked it through a simple application that probably they built in like 5 days. Currently, he created a company called Coma.io, and their goal and their idea is to create a driverless kit that's his words, that will sell on Amazon in less than $1,000 by the end of this year, that you can put in almost any new car. So that's like a completely different way of thinking than Elon Musk or Google or anyone. He wants to create it to be very cheap, so you can just plug and play it into your car and it works. We'll see how he's going to do it. He already have some form of investment in a startup, but we'll see if he'll reach that goal to do that in the end of the year. Okay. So that's, let's say that's the positive side of hacking driverless cars. You take a normal car, you put equipment that you can buy in your PC shop, and you create something that drives itself. But what happens when people that you don't want to have access to your car? And that's something that's a real threat. Most of new cars that you buy that are like a year old have some form of Wi-Fi chip in it. They have some form of infotainment system that connects through Bluetooth, that connects to some kind of radio signals. And those systems are actually very integrated into the car itself. So if you want to, for example, I drive an old Mazda, but still it has some form of connection between the engine and the infotainment system. If I drive faster, the music is louder. That's a very simple thing, but it still proves that cars, even before 10 years ago, were connected, the infotainment system and engines. Today, it's completely connected. You can check all the information through your infotainment system or through the dashboard screen about your engine, about everything. And still, you can connect your phone to that by just clicking like a Bluetooth button and you're connected, or Wi-Fi button, you're connected to the car. So the biggest pitfall of that technology is that it will be very hackable. People could access your car, could drive it, could crash it, could do whatever they like if the technology is not improved quite. So they even tried that in 2015. Two guys exploited a security issue in Jeeps, and they completely stopped the car in the middle of a highway just by connecting through Bluetooth to the infotainment system. They hacked into the engine, and they hacked into the brake system, and they pulled the parking brake on or taking out of transmission. I'm not sure, something about that, while you were in motion on a highway. So that's a very serious thing. Even that happened, but there's even something worse that could happen, and researchers believe that this is a very, very realistic scenario. You wake up, you drink your coffee, you enter your car, you want to turn the car on, and on the screen there's a message that, hey, this car is hijacked. If you want it to turn on, please, I don't know, pay us 50 bitcoins. And that's something that is very serious. Like that's called ransomware, and that could happen to cars that are connected on the internet. Teslas are always connected on the internet. So, for example, you can always update a Tesla over the air. You can always access a Tesla over the internet. You know where it is. You can turn the AC on by using an application on mobile. So you could theoretically very easily hack into a Tesla. And that's the biggest problem with, I said like here, IoT. That driverless cars are IoT. That's Internet of Things. You connect things that didn't have internet connection, they didn't have connectivity. You connect them between each other. There's also one serious thing that will happen, and it will happen that the cars will be connected between them. So that's called vehicle-to-vehicle connection. So you will know the speed of a car that's maybe 1 kilometer in front of you, because that will create a much more safer environment for the car to know what's happening around them. But again, if you hack that large system, you can crash all the cars in the same time. And that's very serious. I mean, that could also happen. So this is, by my opinion, the biggest problem with driverless cars, with things that are connected to each other, is that they're prone to hacking. So I said I would be short. I would like to have more of a discussion than lecture because I'm not that big expert on this, but I would like to hear what you think about the technology and everything else. So, and ask any questions that you want or whatever. Thank you. Thank you. So questions? Ideas? Yeah.
So I think I read that with the self-driving ability of the Tesla car, it doesn't work if you don't have your hands on the steering wheel, or if you take your hands away for more than, I don't know, 10 seconds, it kind of gives an alarm or something. Can you explain a bit more about how this function is implemented?
Yeah, but I think they already cheated on that system. Because if you look, there's quite a few videos on the internet where people don't hold their hands on the driving wheel. So I think it's very cheatable. I don't know. There's a few crashes that happened with Teslas. Not many. I think around 10 or 12 in the last year. Most of them are human errors. That those situations probably wouldn't be handled by a human better than this. But if they had their hands on the steering wheel, maybe they could do something, but most of them didn't have any reaction. So I think that system where you hold the steering wheel is very hackable. I don't think that works that well. Yeah.
How do you feel about moral questions of driverless cars? For example, like the picture which you showed in the beginning, or for example, a hypothetical situation where a car has to choose which biker to hit in the if it should hit one with the helmet on, or if it should hit one without the helmet on, and all the implications of these choices and decisions, which basically will be made by programmers,
Yeah. Okay. Moral implications. I'm not sure that it's gonna work that way. You said it's made by programmers, those decisions, but actually those decisions are made through an algorithm that teaches itself how to drive. Of course, you will give him some form of knowledge in the beginning, but it will learn. And I don't think that it will be a decision to hit one bike or a different bike. I think that if you have enough kilometers and if you have enough data behind it, it wouldn't hit anyone. That's the ideal situation. I don't think that, I think we are quite far from that kind of artificial intelligence that will be conscious about the acts it is doing. This is a machine learning program that learns what it should do and should not do. The only way I see it hitting in the future, not right now. Right now, accidents happen, and that's normal. Those systems are still developing. In the future, the only way to hit the bike is the same. If you would on driving wheel, you would still hit it, but the machine would probably, if you learned the machine to hit bikes, if you drive like that, so you hit other things, other obstacles, then it would hit also. But I think it will be very, very precise in what it's doing in the next 20 to 30 or 40 years. I think those algorithms will be very good and very efficient in that way to know what to do and what to not do. Maybe better than us. We could be drunk, we could be stoned, we could be whatever. We can do shit. The computer doesn't know what drunk means, and I don't think it will have a consciousness by then. So. Yeah.
In case it cannot avoid the accident, that was the question. So if you need to decide who to kill.
Well,
there was an app, a web app on the internet not so long ago. I stumbled upon it by accident. Like, I think it was by Google that like to collect some data on the situation, and just the gentleman that asked the question, like, okay, like if you have on the road two bikers and you cannot bypass them in any way, and you have to choose, and what should the program choose? So like you should. Yeah. So
that's the whole point of the machine learning. They created the web app where they'll test how people react.
So basically you teach it who to kill.
Yeah.
And the people teach the program.
Yeah, the people, I mean, the whole idea of those kind of computational things is to teach the computer how you would behave and how you work. So,
I think another interesting thing here is that to look at the bigger picture, and if all the cars are self-driving, then you have an entire system.
Then it probably wouldn't happen. Yeah.
This is a very small problem. I mean, then there would be one guy with a bike who jumps in front of the road, and everybody would know around him what to do with all the cars. There was I heard another talk about this, like. So if you have a truck and your self-driving car is passing by, then if there's a small child playing behind the truck and there is no sensor to tell it that there's on the car, to tell it that there's a kid there, but if the other cars are communicating and
then you would know.
You saw the kid, then it could tell your car that hey, there's a kid there. Yeah, you still like watch.
Yeah, I mean, my opinion on this technology and the moral implications is this is a good technology. This is something that will definitely change the way people live. And I can explain why I say that. How many of you own a car? Okay, so quite few. How many hours per day do you use the car? I know I use it for less than half an hour. My office is 15 minutes walking distance, so by car it's 3 minutes, and if I use it, so it's less than half an hour per day. So my car is sitting in front of my house or my office for 23 and a half hours per day. And I pay that because I bought the car and I'm not using it. And that's why I'm saying that it will change the way people function. If we have intelligent cars or autonomous cars, I can summon a car whenever I need it and use it just to get from point A to point B, and that's it. I pay for that. I don't pay for the car sitting in front of my house for 23 and a half hours. And that will really change things. It will change the philosophy of owning something. If you own a car, you'll probably use it as a time sharing with other people. There always will be people who will buy a car, but that's a different thing. For a normal common person that uses a car to transport from point A to point B, this technology can really change things. If I can summon a car, it comes, picks me up, takes me wherever it should. Somebody who is near that point summons it, and it will be used for 24 hours per day. And that's the point of productivity, to make something productive on the whole lifespan of the thing. Yeah, so.
Another question. The legal part, to legalize self-driving cars.
Can you repeat the question?
Yeah, so the legal part, to legalize self-driving cars in a country, in what state is that here in Serbia, in Europe? I mean, I know that they have some states in the US, I guess.
Yeah, there's
but
3 states.
3 states.
Yeah, that's where you could test it, not completely drive it. I mean, but
So
in California, you could actually use the car on that autopilot function, but in some other states, you can use it on some highways, not everywhere, but I don't think that the legal part is that problematic. That will happen. I mean,
it's inevitable.
yeah, if you have good lobby behind it, I mean, if car manufacturers enter that industry, and they're following Tesla, they're following Google. If they enter that industry, the legal part will happen in, I don't know, a year or two. That's not problematic. They have very strong lobbies. They put a lot of cash into, especially the US. So it will just be to make a law that will go through the legislation. I think it will work. I don't think that the legal part will be problematic as everything else. So, yeah.
What about responsibility?
Just, Mike.
If my car, like Tesla or Google, kills someone, what about responsibility? How can I explain that was car? That wasn't me.
Yeah, that's something that I don't think anyone is thinking that much at this moment. That's a very important thing. But you know, when the plane crash, you don't actually know if the pilot was in command or the autopilot, and they always say it's like human error. Maybe the pilot could do something, but it was on autopilot. Why didn't he react? So I think there's, yeah, in that moral way, we'll have to develop systems where I don't know, where we know what happened really, and we can do that by logging all the data. We know if the driver was sleeping, well, he shouldn't be sleeping. We'll know probably if he could change something, if he could react and not. If he didn't react, then it is really his fault. I mean, so I think there will be some development on that issue in the future, 10, 15, 20 years when this becomes mainstream. But I think, well, the humanity will surely have some answers on that.
Okay, I have a question.
Yeah.
And it is about, well, in my opinion, the greatest obstacle about self-driving cars is that it is impossible that every car in the world becomes self-driving. That would be the easiest thing possible for the software. And about the hackability of the cars, how about implementing the system used in Bitcoins? So in Bitcoins, every computer in the world that uses Bitcoins, then that has a Bitcoin wallet, is synchronized. And they all have to agree unanimously on the flow of the Bitcoins. So what about to protect yourself from hackers trying to attack your car? What about the cluster of people using the same unanimous software?
What will happen if your car at that point is not connected to the internet? You would not be able to start it. So I can hack a car by passing by that car and looking for its Bluetooth or Wi-Fi. I don't have to be connected to the internet to connect to that car. I can connect it directly by standing next to the car. But if the whole system is synchronized in a Bitcoin way, then if I lose connectivity in my car for some reasons, I probably wouldn't be able to start it, right? Because it would need to check something on other computers and to pull that data back and start the car. So
but that would be the safest option.
it would be, definitely.
It would be unsafe to even start the car, even if there are no hackers in the world.
Yeah, I think that will be the safest way. I don't think that will be possible because people will be enraged because they lose connectivity and they cannot start the car. But that would be definitely the safest way to avoid hacking. I mean, Bitcoins are in that way not hackable.
Thank you.
Yeah.
So you didn't mention Uber, who is also developing a self-driving program.
That's quite
and
new info,
they acquired Auto.
Yeah.
So I wanted to ask you, do you think that the future of autonomous cars is tied to ride-hailing and sharing economy? Because you mentioned something like that.
Yeah, I think it is. I actually think it is. I think that at that point where you don't need to own a car, that we're going to that point. I really believe that because if the car is smart enough to come when I need it, why would I own it? Yeah. Then I would ask, okay, Uber is trying to. Uber has a bit different interests in that because he just wants to push out the drivers because drivers are a burden for them currently.
Then they have a cheaper service.
Yeah, they will have a cheaper service. They wouldn't have problems that they have, for example, in California, where even that you're not, even if you're a contractor, the government in California says that you are employed by Uber and it has to pay you pensions and everything else. So I think their interest into that is to lower the cost of their service. I don't think that they have that idea as Elon Musk does, because Elon Musk in his latest big plan, he revealed that he wants to create a completely ownerless Tesla where you can just use it when you need it and everything else. So I think he has better intentions of doing that than Uber is. But still, yeah, Uber is investing a lot of money. They acquired the company that does that, and they made a partnership with Carnegie Mellon University to develop self-driving cars. So they'll probably be the first that will use it in mass because it's cheaper. But Tesla will, I think, create a better system, or George Hott.
Hello. About your opinion that these Internet of Things will make cars hackable. We have already hackable cars, especially if you buy an expensive car. It will have a black box with GPS and everything, so the insurance company can always see where you are to prevent theft. And also in the next versions, these boxes will be able to disable the car on the will of the insurance companies or the police, as already mentioned.
I already watched on, I think, a few weeks ago in the US. You know, the whole economic crisis of 2008, there was like mortgage and you bought a house, you didn't have income. Nowadays, there's car loan bubble that's going to happen. And mortgage companies that give you car loans, they have a black box, and if you are late one day with payment, they disable your car and you cannot turn it on. And it beeps and the day before the payment, it beeps every 5 seconds. And day after, you cannot use it.
Yeah. So. And the other thing about the moral question, the self-learning system, how do you think this will be put in production, I would say? In my company, you have to have a driving license as a human if you want to control a car. Do you mean this teached system should make something like a driving license? It can be done by simulation or something like this? Would this be a solution?
I read somewhere that kids born in this year will probably not have a driver's license. So they will not know how to drive a car. So I guess a system will be created by that point. When those kids grow up, the only thing they will know will be driverless cars, and they would not know how to drive. Maybe you'll create a system where you teach them how to react in some situations. For example, if you have to press the brake, where is the brake? And if you have to move the steering wheel, or I don't know, press a command on the screen. It will change as time progresses. I really believe that you will have to have some form of license for, I don't know, not owning, but driving in a car that's autonomous. At least, I don't know, first aid. I mean, things can happen, so you have to know how to react on different things, but I don't think the driver license will stay for much long. Maybe it will be like voluntary. If you want to drive a Ferrari from 1980s, you will have to have a driver's license. But if you want to go to work by driving a car, you don't. I don't know.
So. I think the question was about should the car get a driver's license?
Okay.
Teach system. What is built in the car? Plus information learned from the owner over, let's say, 1 week or 1 month.
Everyone is doing that form of analyzing the data they get from all the other cars they have on the streets. So when this comes to mass production, you'll probably have a good starting point on how to teach the car to behave, what to do. I think that computing power and everything is like rising very quickly, and every day you can process more and more videos of what cars are doing and the complete set of data. So at that point, you'll probably have very good starting point when you buy the car. It will not make a collision or something like that. And about like the legal aspect of that car, I'm not sure how that's going to work, but you'll probably have to register it as you do with a normal car, but it will have some different forms of ownership, or I don't know how that would work.
What about vulnerabilities?
Sorry?
What about vulnerabilities? Since every software or hardware vulnerability is something that cannot be patched immediately. So if you have a really critical exploit on the cars, if all of the cars are in use, like self-driving cars, what would happen to the whole of the world?
It would crash.
If cars suddenly need to stop because of a critical exploit.
Crash. That's the whole point of the hackability of things that are connected to the internet. It would crash. You cannot. Everything is hackable, definitely. Yes. Everything can be hacked. You cannot protect it enough. So this is probably the biggest pitfall of this technology, as Ray said, is the hackability. If you would hack the whole system, every car would crash. That's obvious, and people.
Since it takes time to patch something which is.
Yeah, I mean, at that point, 2 seconds is much.
Yes.
So you cannot have a system that have holes in it, and that is quite impossible to have a system that not vulnerable to hacking.
Sorry for interrupting, but is somebody connecting the self-patching AI systems and self-driving cars? That would be a really good connection between the projects.
I think it would be. That would be the ideal case, but then probably at some point the car will kill you. I mean, if you have that kind of consciousness that it knows where it's not good at and where it's good at, probably that's rise of the machines, and that's artificial intelligence that wouldn't like you to summon him when he wants to, I don't know, be in standby mode or something. I don't know. I don't think
I'm not thinking about like real AI or something like that. I'm thinking about the I don't know if you heard about that, the competitions on like capture the flag type of thing on virtual hosts which are targeting each other and self-patching themselves?
No, I didn't. I mean,
that kind of a project connected with the self-driving car, that might be a real benefit to this.
Yeah, probably somebody in the world is thinking about how to do self-patching on this. I mean, that's the same thing as airplanes. Airplanes have to be 10 times safer than cars. I mean, in the car it's like 4 people. In the airplanes it's 250. So, but still, people are hacking airplanes. Yes. Even that's very hard and very hard to do. That there's not so much options for connectivity to an airplane's system, but still they do it. So it would be cool to self-patch, but I don't know how quick that will be. I don't know. I'm not into that topic, so I don't know much about it. But probably somebody is already thinking about it, I guess. Yeah.
Any more questions?
Okay. Thank you guys for your time.